Okay, if we look at these are some of the harder problems that we do in here that I'd expect you to be able to do. And after we go through them, you're going to see that they are not hard problems. They just sound different because of the way they're written. And I've had students say to me, well, we didn't do this in class. Well, yeah, we did. We've already done everything on this page. It just maybe wasn't written the same way. So this one says, write a balanced net ionic equation for the reaction of sodium hypochlorite with sodium thiosulfate in acid solution. The hypochlorite ion is reduced to chloride and the thiosulfate ion is oxidized to sulfate. Now, when you read that, it can feel overwhelming, but there's some key words in here. Net ionic equation. So that tells me that we're going to ignore all the spectators. So when you look at sodium hypochlorite and sodium thiosulfate, who do you think the spectator is? Sodium. I mean, if it's in both compounds, it's probably not doing anything, right? So it's getting hypochlorite and thiosulfate to the dance. But as we read further, it tells us the hypochlorite ion is reduced to chloride. So it's giving us a half reaction. Hypochlorite yields chloride. And thiosulfate is oxidized to sulfate. So it just gave us two half reactions. Now, have we taken half reactions, balanced them, put them back together, and got a net ionic equation? Sure we have. Have we talked about nomenclature, that you better know what hypochlorite and thiosulfate and sulfate and chloride are? Sure we have. Do you remember? Maybe not, right? But at least when you're doing them on the homework, you can go ahead and look at your resources. So these are problems that are starting to combine concepts because we're combining nomenclature with balancing a redox equation. So now we go through the steps. 1 chlorine, 1 chlorine. 1 oxygen, no oxygen. Add 1 water. 2 hydrogens, no hydrogens. Add 2 hydrogen ions. Plus 2 minus 1 is a positive 1 over here, a negative 1 over here, so we add 2 electrons to the more positive side. Now I have a balanced half reaction. 2 sulfurs, 1 sulfur. Add a 2. 2 times 4 is 8 oxygens, 3 oxygens. Add 5 waters. 10 hydrogens, no hydrogens. Add 10 hydrogen ions. We have a negative 2 here. 2 times a negative 2 is a negative 4, and a plus 10 gives us a positive 6, and we have a negative 2 over there, so we add 8 electrons to the right. Now, to get my number of electrons the same, I'm just going to multiply this top one by 4, and I will have 8 electrons on each side. So I'm going to multiply and add these together. So 4 times 2 is 8 electrons, plus 8 hydrogens, plus 4 hypochlorite, plus 5 waters from the second half reaction, plus thiosulfate from the second half. Yields 4 chlorides, plus 4 waters, plus 2 sulfate, plus 10 hydrogens, plus 8 electrons. So I've multiplied the top one and then added them together. Now I'll cancel out what appears on both sides. 8 electrons. 8 hydrogens, 10 hydrogens. So I can cancel 8, leaving me 2. 5 waters, 4 waters. Cancel 4 waters, leaving me 1 water. What's left? 4 hypochlorite plus water plus S2O3, 2 minus, yields 4 chloride plus 2 sulfates plus 2 hydrogens. So at this point, I should have a balanced net ionic equation in acid. And of course, we go back and check now. 4 chlorines, 4 chlorines. 4 oxygens plus 1 is 5, plus 3 is 8 oxygens. 2 times 4, 8 oxygens. 2 hydrogens, 2 hydrogens. 2 sulfur, 2 sulfur. Negative 4, negative 2 is a negative 6. Minus 4, minus 4, 2 times negative 2 plus 2 is negative 6. So we have a balanced net ionic equation. And was that really anything different than what we've been doing the last couple days? Not at all. Did it seem different when you read it? It does. Okay, all those words, if we could just throw the numbers around, it would be easier for a lot of people. Okay, back up. You add electrons when you are done balancing the half reaction for mass. So my half reaction was balanced for mass with the water, hydrogens, hypochlorite, and chloride. So then I added the electrons to that half. Then down here, I had the water, the hydrogens, the sulfur-containing compounds all balanced for mass. Then I added the electrons. So it's the last step in the half reaction. And then you add the two together. Question? Yes, you're multiplying so that you have the same number of electrons on each side.